Way 16 has to deal with melting points, and this concept nearly always requires use of table S because they will frequently include elements in which you have to look up the melting point values for. If you recall, melting point is the point at which a solid becomes a liquid. At this point, solid and liquid are in equilibrium. The rate at which a solid is melting into a liquid occurs at the same rate as a liquid becomes a solid. So let's try some questions that deal with melting point. Which element has a melting point higher than the melting point of rhenium? So you're probably wondering, how the heck do I find melting points for these elements? Well, if you look on table S, it'll give you the values for each of these elements. So go ahead and do that now and see if you can find what the correct answer is. Okay, if you look up the melting points for the following substances, you see that rhenium has a melting point of 3,458 Kelvin, and these are the melting points of all the elements in the answer choices. And while this seems like a lot of work, all this concept is really testing is whether or not you can properly use table S to find and look up melting points. So you see that rhenium has 3,458. The only one that's higher is tungsten, so the correct answer is tungsten. Let's try another problem. In the late 19th century, the Hall-Héroult process was invented as an inexpensive way to produce aluminum. In this process, aluminum oxide liquid extracted from bauxite is dissolved in sodium aluminum fluoride in a graphite-lined tank as shown in the diagram below. The products are carbon dioxide and molten aluminum metal. What is the melting point of the substance that collects at the bottom of the tank? So you have to use the diagram and the text in order to figure out which element they're talking about, and then use table S to look up the melting point. Okay, we see that the substance collecting at the bottom of the tank is aluminum, Al. So all this process requires is to look up aluminum on table S, find its melting point, and we see that the answer is 933 Kelvin. It's that simple. Which element has the highest melting point? Once again, if you can use table S, this problem becomes really simple. Okay, when you look up the melting points, we see that the one with the highest melting point is rhenium at 3,458 Kelvin, so the answer is rhenium. Let's try another problem. Which element is liquid at 305 Kelvin and 1 atmosphere? This problem is deceptively simple, but you'll find that it's slightly harder than you think. See if you can figure out what the correct answer is before I tell you. Okay, for an element to be liquid at 305 Kelvin, it means that the temperature has exceeded the melting point, meaning the solid has melted by this temperature, but it has to be below the boiling point. Boiling point is the point at which a liquid becomes a gas. So we're looking for an element that falls between the melting point and the boiling point at 305 Kelvin. And the only one that fits that criteria, you see, is gallium. At 305 Kelvin, gallium has already melted to a liquid, but it's way below the boiling point, so gallium has not quite become a gas. At 305 Kelvin, magnesium is still a solid, and fluorine has become a gas because 305 Kelvin is way beyond fluorine's boiling point. Iodine is still solid at that point because we haven't quite reached the melting point of iodine. Which element is liquid at 758 Kelvin? Once again, this requires use of table S. Okay, for an element to be liquid at that point, it means that the melting point of that element is way below 758. However, this temperature falls beneath the boiling point. So we're looking for an element whose values of melting and boiling point fall between 758 K. And we see that the only one that fits that criteria is thallium. At 758, thallium has completely melted because its melting point is 577, but it's not quite become a gas. And if you see, all the other elements have melting points way above 758. Therefore, gold, silver, and platinum should all be solids. They haven't quite reached the melting point. Hopefully this helps. Thank you for watching.